Okay, sir, we can start, I think.
Yeah, we can start now. Because I think they will take some more time for joining. So today we will learn about the data cleaning. Do you have any idea about the data cleaning? No idea.
Sir, little bit like you have given in the this assessment, removing duplicates, standardization, outliers, validation.
Yes. If your data has some outlier, then what will be the problem?
Interpretation will be not proper, sir,
Why?
because those outliers will affect the outcome.
Yeah, outliers will affect the result.
Yes,
But
sir.
why outlier will affect the result?
Sir, it will enhance the mean average, and it will indicate that the data, the overall average value will be higher. So if the mean is higher, the other statistics based on mean will be getting affected. For example, t-test and OY.
Yes. Most of the parametric statistics, they depend upon the mean and standard deviation. And this mean and standard deviation, they are easily affected by the outlier. Okay. Therefore, you may get some bad result because of the outlier. So how do you minimize the outlier effect? How can you minimize the outlier effect?
I've been removing them all at all so far. I mean, I've been dealing them, so I removed them.
So
Yeah,
like
that is one solution. Another solution is
when we enter data, like we can mistype, like instead of typing one, we can type we can accidentally type one like that. So if that case happens, like that will make our data outlier. And so we need to be careful when typing the data. But some outliers are like it naturally happens. So in that case, like we cannot remove or delete outlier. We should accept the fact that there is an outlier. So
when there will be outliers, then how do you manage that data? How do you analyze that data? Whether you will, when you will remove and when we will keep the outlier.
So if there are too many outliers, and so if we have a lot of data, and let's say we have 1,000 data and we have a few outliers, we can remove them and then proceed ahead with analyzing the data. But we have a limited data. Let's say we have 60 or less than that, and we still have outliers. Then we will value the outliers and we will switch to a different statistic. I mean, non-parametric statistics based on median as a central tendency.
Yeah, that is true. We have to increase our sample size. Another one, we can go for the non-parametric statistics. Very nice answer. And keep in mind, that is whether the outlier is genuine or it is by mistake, maybe due to the typing error.
So, sir, whenever we go for non-parametric, that means we are keeping the outliers?
We can keep the outliers if the outliers are genuine.
Okay. Because most of the time the chances of typing errors are not that much, na, sir. So
No, typing error is very common nowadays. $1.5 billion loss in the US economy due
Yes,
to the outlier, due to this typing error and other things.
Excel mishaps at JP Morgan and Chase case.
So can you imagine that is how much cost? Okay. Now, Amit, please read it. Data
yes.
cleaning.
In the big data, the role of data cleaning has becomes increasingly significant. Data cleaning, also known as data cleansing or scrubbing, is the process of detecting and correcting corrupt or inaccurate records from a data set. It involves ensuring the data is accurate, complete, and formatted correctly for analysis. Common data cleaning tasks. Handling missing data. Missing data can occur due to various reasons such as error in data entry or equipment malfunction. Common strategies for handling missing data include removing records with missing values, imputing missing values using statistical methods, or using algorithms that can handle missing data. Removing duplicates. Duplicate records can distort analysis results. Identifying and removing duplicates is crucial to ensure that each record is unique.
Okay, one sec.
Okay.
It is written using algorithms that can handle missing data. So what is the meaning? Who can say?
By algorithm, we go by the reference that there are certain specific predefined steps that we follow in algorithm. So there may be some specified steps that are there to handle maybe missing data.
No, there you can use the 99.
Okay. Just we
Okay.
put 99 number.
Yeah. If you find that is your all the data are related are mainly the single number, maybe it is a Likert scale data, this item number from 1 to 5. And then you find some data that is the missing. So there you can write down 99. Okay.
Then
And
during
when
analysis,
during the analysis, you have to find out how many 99 are there in your row and in your column. And if you find that is the 99 is more than 75%, then it is better to remove that particular data.
Sir, I did not understand, sir, algorithm. I did not understand.
Now in Excel, suppose you have the data, and when you collected the data, then suppose you have asked something related to the financial position, and your subject is not able to answer. Okay, so that data is missing data.
Okay.
So when it will be the missing data, then you can use the 99. Okay. And after that, you will find out maybe you have collected 1,000 data. And out of this 1,000 data, how many people they received the 99 and the count of the 99? How many 99s are there? Okay. And if you find more than 75% 99 is there, then you can remove that particular data from your model. Now it is clear.
Actually, theoretically, I have understood a little bit, but not very clearly.
Just to imagine the spreadsheet, Excel sheet.
Yes.
1,000 rows are there,
Yes, sir.
and you have collected some socioeconomic data.
Yes, sir.
And in that data, there is a question, that is, what is the income in your family?
Yes, sir.
And the specific woman who is your respondent, she is not able to answer the correct thing.
Okay.
So she has told you, I have no idea. That
Yes.
means that data is a missing data.
Yes, sir.
So out of these 1,000 people, that data, how do you indicate? Then it is better to use the 99.
Means
And then,
means on the income, what she was going to tell, you have to enter 99.
yeah, because she is not able to answer it.
Yes, sir.
Therefore, you are using the 99. Because if you do not use the 99, then what will happen? It will be revealed that there are some of the missing data. And if the missing data is there, then your analysis will be affected.
So, sir, that means this 99 do not have any numeric value. It is just symbolically there to
Yeah. So
present
you
us.
will 99 is not used for your analysis. Okay. And if you find that is some subjects or some respondents, they have given more missing data, then it is better not to use that particular data. Now
Sir,
it is
I have
clear?
a question.
Yeah.
Sir, I know the description of 99 because I used it in SPSS, but I want to know that at RStudio where I will use it.
Yeah, in Excel, you can write down 99. In SPSS, you can tell that is this 99 is the missing data.
But
in SPSS, you can indicate.
RStudio,
Okay.
So,
Or
sir,
you want
I
to-
asked sir in RStudio how I will input the 99.
no, we
No.
don't have to input it.
In
Is Excel.
RStudio, you are extracting, you are basically importing the data
Am
from
I
MS
audible?
Excel. Okay. In RStudio, what you are
Okay,
doing,
oh,
you are importing
okay,
data
sir, okay,
from
sir.
MS Excel. And MS Excel
Oh,
includes
sir,
the
I got it,
99.
I got it. Okay, sir, thank you.
Yeah. So Amit, next, removing duplicates.
Duplicate records can distort analysis results. Identifying and removing duplicates is crucial to ensure that each record is unique.
I think this is clear to you.
Yes. Correcting errors, data entry errors, such as typos or incorrect values can significantly impact the analysis. These errors needs to be identified and corrected to ensure data accuracy. Standardizing data. Data from different sources may be in the form of different formats. Standardizing data ensures consistency, making it easier to analyze. This includes formatting dates, converting text to lower cases, and ensuring consistent units of measurement.
This is clear?
Yesterday we did that. It is same, sir.
Yeah, that is one side, but here it adds something more.
Yes, sir. Sir, this thing, the converting text to lowercase, is
Yeah,
about.
you can convert the text into lowercase, or you can convert the text into the uppercase. So everything is possible in MS Excel. You can write down equal to upper bracket the cell number, then automatically that cell will be upper. Or if you write down lower, then it will be the lowercase.
Sir, how does the upper or lowercase affects our data part? I mean,
Yeah, because they are treated as the distinct variable. For example, you are writing Mumbai and Sham has written M small letter and Sham has written M is capital letter. So this capital and the small letter, the word will be assumed as the two different variables.
okay, sir,
Okay.
got it. Got it, sir.
Therefore, you have to maintain the consistency. Next.
Handling outliers. Outliers are extreme values that differ significantly from other observations. They can skew results and may need to be investigated to determine if they are errors or legitimate values. Depending on the analysis, outliers may be removed or adjusted.
This is clear to everybody?
Yes, sir. Yes, sir.
Sir, adjusted means what, sir?
Yeah. For example, there is an outlier and you think that this outlier is genuine outlier. If it is genuine outlier, then you can do this without outlier. First you do the analysis and after that you include the outlier and then you do the analysis. So two analyses will be done, that is without the outlier and with outlier, because the outlier is genuine outlier. Is it clear?
Yes, sir.
For example, socioeconomic status, maybe it is 1 lakh per month, whereas the other people are saying it is around 15,000. Then what will be? This 1 lakh, that will be considered as the outlier.
Yes, sir.
Okay. So this data will affect your model. Therefore, it is better to adjust the outlier. You can keep the outlier initially. After that, you remove the outlier and then you can show that is due to this genuine outlier, your result was affected. That you can show. Next one is the
Validation.
validation.
Ensuring that the data meets the required criteria is essential. This includes checking for valid values, ranges, and data types.
Yeah, whether the values that you have typed, that is the correct or not. So when you analyze the range, then you will get the information about the values. For example, suppose by mistake you have typed 55. In case of the rating scale, 5-point rating scale typing. Okay. So when you will write down the range in bracket the vector, then you will get that is the range is different. 55 is there. Automatically, you can get the idea that there is some typing mistake. So before using your data in the analysis, pre-processing of data, that is vital. If you do not pre-process, then there will be high probability for poor quality of data, and whatever the information you will provide, that may not be the correct information. This is clear?
Yes, sir.
This is
Yes, sir.
called data quality. You have to check the data quality first. So this is called the pre-processing. Now I am going to the another important area, that is called data transformation. Hello, Kobita, are you here?
Yes, sir.
So please you read data transformation. I am sharing.
Yes, sir. Shall I start, sir?
Yeah.
In the era of big data and advanced analytics, the significance of data transformation has never been more pronounced. Data transformation is the process of converting data from its original or raw format into a more suitable format for analysis and interpretation. The process is critical because raw data, open, unstructured, and complex, needs to be cleaned, normalized, and reshaped to be useful in driving actionable insights.
Okay, one sec. So when you will get the data from the respondent, so that data is the raw data. And when you pre-process the data, then you have seen that the raw data has the different units of measurement. Then you have to find out the parity in the units for your analysis of the specific variables. Therefore, you are doing the data standardization. So the standardized data, that is the transformed data. Another thing, that is you have to check whether your data distribution maintains the normality or not. In the last class, I have shown you the QQ plot to understand the normality of the univariate data. I have shown you the outlier in case of the bivariate data. Can you remember? The outliers in the bivariate data?
Yes, sir.
Yeah, by using the regression line, correct. Now you did.
Understanding data transformation. Data transformation encompasses a variety of techniques and methods to prepare data for analysis. These include data cleaning, normalization, aggregation, and enrichment. Each of these steps plays a vital role in ensuring that the data is accurate, consistent, and in a format that can be effectively used by various analytical tools and methodologies. Data cleaning. This involves the identification and correction of errors and inconsistencies in the data. Missing values, duplication, records, and outliers are common issues that need to be addressed. Data cleaning ensures that the dataset is accurate and reliable, providing a solid foundation for further analysis. Data normalization. Normalization is the process of scaling data to fall within a specified range, typically 0 to 1. This is particularly important in machine learning algorithms, where differing scaling of input features can be lead to biased or inaccurate models. Normalizing data ensures that each feature contributes equally to the analysis, improving the performance and accuracy of the models. Data aggregation. Aggregation involves summarizing data to provide insight at a higher level. For instance, sales data can be aggregated by week, month, or quarter to identify trends and patterns over time. This step is crucial for generating summary statistics and dashboards that aid in decision-making process. Data enrichment. Enrichment is the process of enhancing the dataset by adding additional information from external sources. For example, demographic data can be enriched with socioeconomic data to provide deeper insights into consumer behavior. This step increases the contextual value of the data, making it more informative and actionable. The ratio of data transformation in the modern analytics. In contemporary data-driven environments, the role of data transformation is multifaceted. It not only prepares data for analysis, but also ensures that the data meets the quality standards required for accurate and reliable results. Modern analytics relies heavily on the data transformation to enable advanced techniques such as machine learning, artificial intelligence, and predictive modeling. Improve data quality. High quality data is the cornerstones of effective analysis. Data transformation process ensures that data is free from errors, inconsistency, and bias, leading to more accurate and reliable results. Enhancing analytical capabilities by transforming data into a suitable format, analysts, and data scientists can leverage sophisticated analytical tools and techniques. This enables the extraction of meaningful insight that can drive strategies, decision, and innovation, facilitating data integration. In many organizations, data is sourced from various systems and platforms. Data transformation allows for the integration of disparate data sources into a cohesive data set, providing a comprehensive view of the business landscape, enabling scalability. With the growing volume of the data, scalable data transformation processes are essential. Automation of data transformation tasks using ETL, extract, transformation, loading tools and pipelines ensure that large data set can be processed efficiently and effectively. Challenges in data transformation. Despite its importance, data transformation is not without challenges. The process can be time-consuming and resource-intensive, requiring specialized skill and tools. Additionally, ensuring data privacy and security during transformation is a crucial concern, especially when dealing with sensitive information. Complexity. Transforming complex and unstructured data can be a daunting task. It requires a deep understanding of the data and the appropriate techniques to apply. Resource intensive. Data transformation often demands significant computational resources and skilled personnel, making it a costly endeavor for organizations. Data privacy and security, ensuring that data privacy and security are maintained throughout the transformation process is crucial, particularly in industry dealing with sensitive or personal information. Conclusion. Data transformation is a vital process in the modern scientific analytical landscape. It ensures that raw data is converted into a clean, structured, and useful format, enabling accurate and reliable analysis. Despite its challenges, the benefit of data transformation, such as improved data quality, enhanced analytical capabilities, and seamless data integration, make it an indispensable component of data-driven decision-making. As the volume and complexity of data continue to grow, the importance of efficient and effective data transformation processes will only become more pronounced.
Okay, so is it clear to all of you or any question?
Sir, it is
Why the data transformation is important and why it is called the machine learning, artificial intelligence that is also involved in data transformation. Can you tell?
Normally, sir, maybe that when the data is present before us without transformation, lot of hidden values or hidden meanings or interpretations are present, which can be enhanced by data transformation.
Okay.
If you have examples, then sir, then I think it will be good if you could give some examples.
Okay, give the example.
No, actually, I am not knowing the example, sir. Actually, means like cleaning, transformation. If there are certain examples, that is what I am asking.
Okay, okay. Yeah. We have collected some data from the industry about the safety consciousness, safety behavior. Okay. And when we do the analysis, particularly central tendency and variability, based upon the raw data, then we have noticed that some of the variables, their central tendency is very high. Okay, that means those variables are very much important for the safety behavior. Okay. And when we do the correlation, then we have noted that is those variables which are very high in the central tendency, they are not significantly, or some of the variables, they are not highly correlated with the total score. So what does it mean? That means when you deal with the raw data, there is a chance of error. But when you will use the transformed data, then you can minimize the error. Okay. Now I am showing you.
Sir, I have a question. Yeah.
Yeah.
So, sir, yes, sir. So, speaking of transformation part, so suppose whatever data we get, we can, I mean, when to do the transformation? Is there any do's and don'ts when to do, when not to do?
No, the transformation is important. Transformation, particularly, it is very much important for the multivariate analysis. For example, you are using the factor score. Okay, by using this principal component analysis. After that, you can use the factor score. So this factor score will be the transformed data.
Okay. So, sir, if I'm getting correct with the factor score, how do we obtain factor score?
Or you can, if you take only the predicted score, that is also the transformed data.
Okay.
But sir, like means when you are saying that when we do the principal component analysis, that is transforming data transformation.
When we do the principal component analysis, then we will get some of the components. Okay.
Yes, sir. Yes, sir. We get.
And these components had certain loadings.
Yes, sir.
And you are multiplying this loading with the original score plus another value. Okay. Then you will get the score based upon that particular component score. And that component score will be your transform data.
So, sir, means when, how do we come to a conclusion that we need a data transformation, or what are the requisites? Means whenever we are doing multivariate statistics, it is very important to do data transformation.
Data transformation is very, very important.
Okay, means
you have to transform the data.
Okay, so when we write a research proposal and our proposal ensures.
Yeah, we definitely.
Okay, means in our proposal only there are a lot of variables we are dealing with. So we are dealing with multivariate statistics. So, but obvious we have to do data transformation. Okay, sir.
When you want to do the multivariate analysis, then data transformation is automatically, it will come.
Sir,
You have to, yeah, Kesh Kavita.
sir, when we construct the question here, just like one domain has 5 questions.
Okay, now
Question,
I am showing you one of our research paper, and I am going to present this paper in Bangalore, maybe on 11th July. So I am presenting you this to you so that we have followed the multivariate modeling. We are testing the test-retest reliability using the multivariate modeling and the bivariate. I am showing you the data. It is the test-retest reliability, okay? This is clear now. So here you can find out the domain. For example, the domain is self-awakening, emotional control, systematic, and this is the alpha value. Okay. And this is the mean, test mean, and this is the standard deviation. This is the retest mean and the retest standard deviation. And this is the pair t-test. After that, it is the p-value of the pair t-test. Next is the test-retest correlation. And you will find the correlation is very high. Okay, 0.96, 0.91, like that. That means the whatever the values I have tested, their test-retest reliability is very high.
But
Now,
the alpha of systematic is less. Still, you are retaining it.
yeah, alpha systematic is less, and that means maybe the items are not enough meaningful to the subject. Okay, but interesting point is this systematic data. Here you can find out the
Yes, sir.
correlation is 0.91.
Yes, sir. That's interesting.
Okay. Here you can find out 0.9. And if you check it, it is the mean is 3.63 test data, and the retest data is 3.65. Okay, almost same. The standard deviation is 1.154, and this is the 1.172. Okay, so
Okay, got
here
it, sir.
you will find that is not, that means when you are dealing with the, this is the univariate model, univariate approach I have followed here.
So, sir, here data transformation means what, sir? Please tell us.
And no, this is the initial model.
Okay, sir.
This is the univariate approach, and this correlation is the bivariate approach. So you will find that is the, though the alpha value is poor, but the test-retest reliability is very high. That means Cronbach's alpha, that is the internal consistency, that is poor. But the test-retest reliability, that is time consistency, that is high. that indicates there is no relationship between the convex alpha, that is the internal consistency of the items, and the time consistency. They are not same. They are totally different. Now I am showing you this is the hierarchical cluster analysis. Okay. This is visible to you?
Yes, sir.
Can you please zoom it a bit?
Control plus.
Yes, sir. Fine enough.
Okay.
Yes, sir. Thank you.
So this is the self-awakening. And here you will find that is this one is the test data and this is the retest data. So test data and the retest data, they are close to each other. Here, this is the third item and this is the first item. This is second, this is fifth, and this is the fourth item. Okay. And here you will find that the two clusters are there. This is the first cluster. This is second cluster. Okay. Here again, you will find the similar type of cluster. But when you go to the systematic, there you will find more number of clusters.
Sir,
Okay.
I didn't understand the part systematic.
Systematic is the value. Whether you are following the systematic in your profession, systematic approach you are following or
Okay.
not.
Okay.
So there
Okay.
are some of the items are there.
Okay.
And
Okay. Okay.
if because you are also dealing with this type of questionnaire, I think you have already given the responses. And here we find
Okay.
that is the more number of clusters are there.
Sir,
But
is this the this study worked on the same scale we our response inputted?
it is not your response. It is another response.
I know, but the scale is same.
Yeah, same.
Okay, thank you, sir.
So
I
now
want to
here
know.
we can find out more number of clusters. So this is the multivariate modeling. Okay. So when
Okay.
we use the multivariate modeling, then we will get much information in comparison with the univariate or bivariate model. So that is the advantage of the multivariate modeling. Okay, here again you can find out that is the item number 5 for the test and retest. They are close to each other. So in considering the test retest, they are very close to each other, but their internal consistency is poor. Possibly due to that reason, there are more number of clusters. So here you can find out 3 clusters broadly. This is clear? Or any question?
Sir, I did not understand how it is multivariate here, sir.
Because more number of variables are there, no? More number of variables are there and they are classified here.
Domains you already had, na sir, this like systematic, non-self-open.
Yeah, when we deal with the total score, then that is the univariate approach.
Okay.
Okay. But when we consider the items separately and how the items, they are close to each other, Shane, using the hierarchical cluster analysis, then it will be considered as the multivariate statistics. So here we follow the multivariate statistics. More number of variables are there.
Sir, how do we read clusters in here? How do we read this is one cluster, this is second cluster, this is
Okay, when we will teach you the, I'm not sure cluster analysis is in your syllabus or not. If it is there, then we will teach you, and there you can find out how to do the cluster analysis.
Okay, sir.
People component analysis is there in our syllabus, sir, but
yeah, principal component analysis is in your syllabus.
Regression is there. ANOVA is
yeah,
there.
regression is there.
ANOVA is there.
Yeah, yeah. So the cluster analysis is not there. Okay. So you will learn later on cluster analysis.
Sir, here just like we have taken one single domain like this challenging. So here in this hierarchy, this
again, this is the two clusters. One cluster has some subcluster. Okay, and basically there are two clusters. One is the main cluster. This is the main cluster. It includes 8 variables are there, and this is the another cluster. It includes only the 2 variables. But here you can find out the variables, they are close to each other. And when you find out CHR, that means the retest data. And CH3, that means it is the test data. So test data and retest data, they are close to each other.
So under the challenging domains, you had different items.
Yeah, different 5 items are there.
Okay, like
5 items are there, and when I am dealing with the total score, okay, and the correlation between the total score, test retest, then I find that is the challenging is 0.95. Can you imagine? It is 0.95. And the Cronbach's alpha is 0.8.
So summary value, like summary value of challenging of test and retest mean is significant at 0.95.
Yeah, yeah.
But when we go inside the challenging domain, like different items, 5 items here, 5 items there. So 5, when we correlate them, that is multivariate.
Yeah, when you are dealing with the 5 and 5, then it will be the multivariate.
So that is clustering here.
That is the cluster. Because there are 5 variables. But here it is the univariate.
So sir, now when we are dealing with 5 multivariate, so where is the data transformation? What means what we will label as data transformation?
Okay, that is when we are writing the R script for this cluster analysis, there we have transformed the data.
Means there is command.
In the program, there is one algorithm. In the algorithm, we have transformed the data.
So before doing cluster analysis, whatever that command you are going to give, that is transformation.
Initially, yeah, that is better. If you transform the data, sorry.
So there is a proper command in
that is the standardization. That is the scale. I have already told you that is the scale command. So scale bracket the vector. Then the vector will be transform score. the raw score will be changed. Now, any question about the transform score? Data cleaning, data
So
transformation?
here, sir, date transform score is what, sir, here? Like this is a correlation, this is a significance. So what we will call transform score?
When we standardize our data, raw data, then that particular score that will be considered as the transform score.
So it is in the paper, sir, somewhere.
Yeah, definitely. It is a standard score is the transform score.
And so the scores that you have transformed, that's the one you have taken
Score
for this
minus
analysis.
mean divided by standard deviation. So your original score minus mean divided by the standard deviation. That is the formula of that standard score. T score, that is the transform score.
So this is
Predicted score, that is the transform score.
in these
Principal
columns.
component analysis, factor analysis. So wherein you will add or you will multiply some of the weightage with the original score, then that original score will be considered as the transform score because the data has been transformed. Factor score is the transform score.
So maybe one last query, shall I?
Yeah, you can ask.
So sir, suppose I have a data and I want to see how many components are there in this data. I'm developing a scale. So first I transform my data, or rather shall I go directly to the dimension reduction and then EFA?
No,
and then
what is your purpose?
my
You
purpose?
have the data, you will not transform the data.
Okay.
If you find that is the data does not provide you much meaning,
okay,
then you can transform the data.
Okay. Otherwise, I can directly go to.
Because, for example, here I have noted that is the correlation is high.
Yes, sir.
But the alpha value is low.
Yes, sir.
That means there is some discrepancy.
Okay.
Therefore, I have transformed.
Okay.
Otherwise, transformation is not required.
So it is not a necessary step for a multivariate analysis.
No.
Not a mandatory
It
step.
is not. And when you want to do some multivariate modeling, then
Yes.
transform score is important.
Multivariate modeling as in?
Yeah. For example, principal component analysis, and based upon that principal component analysis, you have the 16 variables. Okay.
Yes, sir.
And
yes.
when you do the principal component analysis, you will get only the 5 components.
Yes, sir.
Okay. Then the 5 components had certain loadings.
Yes, sir.
And you will multiply the raw score with the loading.
Okay.
And some of the multiplication that will be considered as the transform score.
Okay, sir. Got it.
So that is the important part. That means you are not interpreting the result based upon the original score. You are interpreting the result based upon the transform score. I think now it is clear to all of you. Or still you have the question?
Actually, I think, sir, we will, when if there is any practical, like when we are actually doing, So
Yeah,
then
yeah,
better
that is true.
understand it.
Sir, shall
For
I?
that reason, I have requested you, please you collect at least 200 data, then I can show you.
Sir, I have some data. Shall I run the EFA if you allow me?
Sure, sure.
Okay. Just a minute. Opening, sir.
You want to use SPSS or
Yes, sir.
R?
SPS. SPSS, sir.
Okay. So you are lucky that Shubham is showing you the data.
So, my screen is visible to everyone?
Yeah, yeah, your screen is visible, very much visible.
Yes.
Okay. So, basically, what I was trying to do is I was developing a scale, and
Okay.
I have these many number of items. Now I wanted
Only
to
10 items are there.
no, sir. Yes, sir, only 10 items are there. Actually, I have
Okay.
another. Like, just check. Yeah, this one is another one. Yeah. So it has 16 items, if I'm not wrong. Yes, 16 items they are there, and
Okay.
it's a bidimensional scale. A1 is one dimension, and A2 is another dimension. So basically, technically, two components has to be there. So so I'm running the EFA. Based on eigenvalues. Rotation, I'm keeping very max.
And you got the option.
I'm suppressing the less value of factor loadings. Shall I keep the 3 or 4?
It depends upon your theory. I
I'm
have no
keeping, I'm
idea
keeping, I'm keeping 4. I'm keeping 4.
which
I mean,
variables each one.
just for the sake. So I'm expecting 2 components, but here it is coming 5 components.
Oh, so
Although
this
this,
is your loading.
yes, sir, these are my
This
loadings.
rotated factor, no? So,
Yes, sir.
so actually you have the 15 variables
16.
and now it has been converted into 4, basically 4.
Okay, yeah, basically 4.
You check the scree test,
Which test, sir?
scree plot.
It's a scree plot. Yes, sir, it's up there. I think I did not check on the scree plot. Let me just extract. Scree plot I did not check. I'll run again. I think now I may be having scree plot. Yes, sir.
Yeah, so here we find only the 4. No?
Yes, sir. Clearly
4.
4. Clearly 4.
Yeah, so 4. Eigenvalue is 1, 2, 3, 4.
So,
So 4 factors are there.
yes, sir.
So now you go to your loadings,
Yes, sir.
rotated.
Yes, sir. Rotated component matrix.
Yeah, so what is your data? The first one, H1.
Yes, sir.
So H1 original
A1.
score. Okay, multiplied by 0.80.
So that means, sir, H1, where is H? H1. Okay, yes, sir. This H1.
H1. Yeah, yeah. So this individual's original data.
Okay, this is
So
5, 5, 1, 5, 5, 5.
5 multiplied by 0 point something. What you have
802.
written. Plus A1 into 0 point something, 75.
Okay.
And then plus
C1,
C1 into
whatever the value
83.
will be, C1.
Yeah.
Okay. Into 83.
After that, E1
Okay.
into 0.59.
Okay.
And then you will get the sum.
Okay, then I'll get the sum.
Yeah.
So this will be
And
the
before
standard
that,
score.
yeah, before that, you have to check the alpha value.
Sir.
These 4 items.
Yes, sir. H1,
You
A1,
go to
C1.
analyze.
Oh, yes, sir. Alpha value.
HACE.
Here,
Now you take
H1,
A1,
A1,
C1,
and E1.
E1.
Sir,
Then alpha value is
0.706. 0.706.
yeah 0.71. 0.71. That means the internal consistency is high.
Yes, sir.
Not very high, but high.
Yes, sir. Acceptable.
So like that, you have to do the same thing for the number 2, number 3, number 4.
So in this way, I am
You have to find out the convex alpha. So you can get some idea, that is whether the internal consistency is good or not. If the
Okay.
internal consistency is good, then you can do this sum.
Okay. So after multiplying this value, so 0.802 to the first value of H1 to all the values of H1
Yeah.
and adding them with 0.759 into all the values of A1 respectively, adding them. So if we add all of it,
Not the add, simple. It is not 0.80 plus 0.75. I have told you it should be the original raw score multiplied by the weightage. This is the weightage. Okay.
Then
So
whatever
raw
value
score multiplied by the weightage. After that, again, another raw score multiply the corresponding weightage.
Okay.
And you have to do the sum. Then you will get the factor score.
Okay. And that is a transform score.
Yeah, that is a transform score. That
And
is
then,
not the raw score.
And then we'll check the consistency. If that is there, then we can go ahead with the further.
Yeah.
And sir, but it is a mandatory step. This one is a mandatory step. I mean, multiplying with the raw score of this value and then.
Yeah, because this is called the variate. We are talking about the multivariate. No?
Yes, sir.
So variate does not mean only the variable. Variable multiplied by the weightage.
Yes.
If the weightage is not multiplied, then you cannot say it is a variate.
Okay, sir.
Okay, it is just like regression equation. You are also multiplying the weightage with the raw score. Y equal to A plus BX. So B is the weightage multiplied by the X score.
Okay, sir. Got it, sir.
Clear?
Yes, sir.
So
I'm stopping the
BX1
share.
plus BX2, BX3, whatever that they are. So B is the weightage. B is the coefficient. I think now everybody has understood the importance of transform score.
Yes, sir.
I think when you collect the data and those other things, I think.
Yeah, that is the beauty of multivariate modeling. The more data you will collect, then you will get the lot of information about the data structure.
Sir, can you explain me the little bit data aggregation? I
Data
didn't understand.
aggregation, that is you can do the average.
Okay.
It is a simple average. But be careful, that is by using the average, whether your data will be inflated or not. Usually it does not inflate because we were following the central tendency. So there will be no chance for inflation. But again, you have to check.
Okay, sir.
And the aggregation, that should be based upon the equal probability hypothesis.
Okay.
Okay. I
Yes,
think there
thank
is no question now. Shubham, thank you.
Anytime, sir.
Since you have shown, and
Thanks
the
to you, sir,
student,
for helping us out.
so they have clear idea. I think now you can also understand the factor score.
Yes, sir.
I published one research paper, that is the personality factors. of different occupational groups across the different metropolitan cities in India. There I have followed this model. Farah, do you want to add something?
No, sir.
You have
I
some
think
data, no? I think
yes,
data has
sir.
been transformed. Okay.
Yes, sir. Data is there, sir. Do you want to do the analysis now or you want to do it in the next class?
Students, can you wait for some time? Or you want to leave now?
I can, sir. I can wait.
Okay, so Shubham can. Amit, Mohammed, Rafiur?
Sir,
Sir, I think we need to study today, then further things.
Okay.
so what
So
we
Farah,
need,
you can share.
Okay.
what Farah is sharing, sir?
Farah will share your
Yes,
responses.
yes. Amit, we will show you how to do the data analysis,
Okay.
the value responses, right? So these are your responses. I'm going to upload this file in RStudio. So I'm taking it from SA1.
Only 5 data are there. We have to increase the data size.
Yes, sir, because they are not responding, sir. Rafiul, what about what's her name? Shati
Can you increase the size?
yes, sir. Sure. So, but I have to upload it in the RStudio, no?
No. RStudio
No?
not required.
Not required. Yes, sir. Can you see now, sir?
Yeah. So now you can calculate the average and standard deviation.
Sir, in Excel,
Yeah, you can write down equal to average.
sir.
Bracket K2 colon K7. Enter. Then you write down the standard deviation below
Yes,
equal to STDEV.
yes, sir.
ST, T for Tata.
ST. Yes, standard. The day is standard deviation, no? Standard. One second. I have to write down something.
What you are writing. Okay, now you select both.
So drag it now.
Right side.
Yes, sir.
Then the standard deviation. Now after the CB,
CB.
after CB,
Okay.
what is the last one?
TC.
No, not there. You go
Okay.
below. Yeah, there you write down equal to average, bracket,
A8.
from first to last.
First to last, no, sir. So K8 and K9.
What is your variable?
Seven.
CB8.
CB.
No.
Oh, yeah, CB.
You have to have
So
it will be the grant.
Yeah.
So you are starting from where?
So from K8.
K.
Na?
Okay,
8.
yeah. K8 to
CB8.
equal to average, bracket, K8 colon
K8.
CB8.
Yes, sir.
Enter. So this is the grant
Yes, sir.
equal to
The same, so sorry, it's standard deviation, no, now.
So this is the impression. That means you are giving the importance on all the values. That is, in average, you are giving importance on the values, and the within group variability is very less. So this is the observation, but this is the univariate statistics. Though there are multiple variables, but whatever the information you are getting, only this mean and the standard deviation, that is basically the univariate model. Okay. So this is the interpretation. It is the univariate. It is not the multivariate.
So may you please repeat the interpretation with after seeing the mean and average, mean and SD?
Because it is 3.67. That means 4. That indicates, that is, whatever the values are there, you are practicing those values by your opinion, and you do not have much variation within group because your standard deviation is 0.30.
Okay, sir.
Okay. Okay, thank you, Farah.
Thank you, sir. Thank you, students.
Thank you, sir.
So if you collect more number of data, then I can show you better result.
Farha, would we have to collect?
Hello, Farah.
Yes, sir. So, Rafur, you have to collect 20. You have to collect data from 20 individuals. Okay, age range is 20 to 50.
I asked to say, I asked that minimum 20 or maximum 20.
Maximum 20.
Okay. I want to collect more than 20. I was
Okay, no
like,
problem. If you can collect more number of data and the data is good, then fine.
Very good.
okay.
Very good of you. But Rafur, I have sent you the questionnaire in English. Okay.
I saw the mail. Yeah.
Very good. Okay. Thank you, Rafur.
Thank you.
And Dr. Amit, you can conduct this test on 17 years old also, but in this course, you have to conduct this on 20-year-old.
Okay.
Yes.
Thank you.
Oh, you're welcome. Okay, sir, we can close the session now.
Yeah, because you are measuring the values, and values usually develop when the individual becomes adult.
Yes, sir.
Because value is very much internalized. Otherwise, your value will be very much flexible. Therefore, if you collect the data from the adult population, the value data that will be more stable.
Okay, sir.
Okay, thank you, everybody. Good night.